Let's consider the overall process of urine formation. The nephron is the unit of kidney function. There are about 1 million nephrons in each kidney, and each nephron has the ability to make some amount of urine. So let's take a closer look at the nephron. Here is the glomerular capsule, opening into the PCT, or the proximal convoluted tubule. Here's the nephron loop, opening into the distal convoluted tubule. And finally, we have the collecting duct. You should be able to draw this on your own and label it. Here in front, we have the glomerulus, the afferent arteriole, and efferent arteriole. Molecules move from the glomerulus into the glomerular capsule. This is the first stage of urine formation. We call it filtration because molecules are filtered through the glomerulus. The next stage of urine formation is the movement of molecules from the PCT to the peritubular capillaries. This is called tubular reabsorption. Tubular reabsorption occurs in many parts of the nephron, but majority of it takes place in the PCT. The next stage of urine formation is getting rid of molecules that the body does not need. They could be either toxins or they could be ions for ionic balance. It's removal of certain ions that can bring about acid-base balance. So this is the removal of unwanted molecules. So that's called tubular secretion, and that happens in the DCT. The final stage of urine formation is water conservation. Depending upon the needs of the body, the water needs to be conserved or lost. And that is mostly happens in the collecting duct, and we call this stage water conservation. And whatever comes out of this process is that little drop of urine that you see. Filtration is the first stage in urine formation. This takes place in the glomerulus. The glomerulus acts as a filter, and the glomerular capsule is what catches the filter. Here we see the PCT. The glomerulus gets its blood from the afferent arteriole, and the blood leaves the glomerulus via the efferent arteriole. Small substances can pass through the glomerulus and end up in the glomerular capsule and the PCT beyond. Larger substances, such as formed elements and plasma proteins, cannot pass through the filter, and so they end up in our general blood circulation. If these large components of the blood end up in our urine, then this means that the filter is broken. Now, the substances that can pass through the filter are glucose, amino acids, ions such as sodium, potassium, calcium, chloride, water, and urea. You want to imagine the filter to be like a tea filter. The big tea leaves stay in your filter, and those would be the formed elements and plasma proteins. And the small tea leaves that actually pass through the filter and end up in your cup are the glucose, amino acids, ions, water, and urea. Here we have the main difference here is what can and cannot pass through the filter. That's the main thing. Tubular reabsorption takes place at the level of the PCT. So solutes and water move from the proximal tubule to the fenestrated capillary, which is the peritubular capillary. So we're talking about the movement of glucose, amino acids, ions such as sodium, potassium, chloride, etc., and water that move from the PCT to the peritubular capillary. The third stage of urine formation is tubular secretion. This is the movement of molecules from the capillaries to the renal tubule. Whatever ends up in the renal tubule will become urine. There is no more absorption beyond this point. So let's take a look at the capillary, which is the peritubular capillary. This is also a fenestrated capillary. The part of the renal tubule that does most of the tubular secretion is the DCT. So let's imagine that this renal tubule section is the DCT, and molecules move from the peritubular capillary to the DCT in the opposite direction as we've seen. The molecules that get secreted are potassium, hydrogen ions, and some toxins. The last stage of urine formation is water conservation. This happens largely at the DCT and the collecting duct. On a hot day, the body loses water via sweating, and so the posterior pituitary produces a hormone called antidiuretic hormone, or ADH for short. ADH makes the DCT and the collecting duct more permeable to water, and so water is reabsorbed at these places, and the urine that is produced is in a small quantity and it is concentrated. On a cold day, the body loses less water via sweating, and so the amount of ADH that is produced is less or not at all. In the absence of ADH, the DCT and the collecting duct are impermeable to water, shown by the red line. As a result, water is not reabsorbed here, and the urine that is produced is in large quantities and it is dilute.